Hello guys, welcome to our physics class for today. This is Normal Science Tutors Online and I remain Otubo Michael. Please, if you have not subscribed to our channel, what are you waiting for? Click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you. You can reach us through the WhatsApp number that is showing on your screen. Is that okay? So for today, we are going to be discussing simple harmonic motion. We'll be talking about circular motion. So today we are discussing simple harmonic motion. So please get your writing materials so that you can get ready for the class. Please, you can also invite your friends so that they can come and join this physics class online. We are bringing physics direct to your very doorstep, and our aim is to make the study of physics interesting and very simple for you. So welcome to our class for today. We are going straight now to the topic for discussion: simple harmonic motion. So what is simple harmonic motion? Simply put, it is a to and fro movement of a body or of an object through a central point or about a central point. Is that okay? So example is the motion of a simple pendulum. Right? When you tilt a simple pendulum to one end and you release it, it will undergo simple harmonic motion. Or the motion of a stretch spring. When you stretch a spring and you release it, right? If there's a weight on it and you release it, it will be moving to and fro, up and down. Such motion is what is called simple harmonic motion, right? So simple harmonic motion, simply put, is a to and fro motion of an object or particle whose acceleration is directly proportional to its displacement from a fixed point and is always directed towards that point. So that is simple harmonic motion. Now, any object that is undergoing simple harmonic motion has what is called amplitude. Amplitude. If you draw the waveform, you will see that the wave will be in form of regular circles. So the amplitude of a simple harmonic motion is the maximum displacement of a body from its central or equilibrium position, and this amplitude is equal to the radius. It is equal to the radius of the circle that will be formed for a body that is undergoing simple harmonic motion. So sometimes if you look at some waveform, we have something like this. Okay, so you have something like this. So this distance from this point to this point is the amplitude of the body. Now this amplitude, if you complete this circle, this amplitude is equal to the radius of this complete circle. Is that okay? So this is what amplitude is. Now for a body that is undergoing simple harmonic motion, it has what is called the period. It has what is called the period. So the period is equal to the number of cycles or vibration or oscillation, or it is equal to the time taken for the body to complete one cycle or vibration or oscillation. So period is given as time taken all over number of oscillation or number of vibration or number of cycles. Is that okay? So that is period. The frequency is given as the number of cycles or oscillation per second. Number of cycles or oscillation per second gives you frequency. So frequency is given by F is equals to N all over T. Number of cycles per second, that is frequency, right? So and frequency is measured in hertz. Frequency is measured in hertz. So if you look at the formula for frequency is number of cycles all over time if you compare the two equations that we have, that period equals to t over n, and that f, frequency, is equals to n over t, number of cycles over time. This, if you look at this equation, you see that they are related. Okay, the equation for frequency is the inverse of the period, so frequency can actually be written as 1 over t, 1 over the period, and also the period can also be written as what? 1 over f. So you need to take note of all these equations because you'll know when to apply them if you are solving any problem. That okay, so period is 1 over f and f is equals to 1 over t, right? So please take note of these equations of frequency and period. Okay, so we're looking at equations of simple harmonic motion. We have already discussed the one for period and frequency. So we'll be looking at another equation for angular, when you have angular velocity. So we'll look at the relationship between angular velocity and the period and then the frequency. Okay, so when your time t is equals to the period and is the time for one complete oscillation, we have said that theta, for a body that is undergoing circular motion, theta is equals to the 360 degree, which is equals to 2 pi radians. And we got that in our previous lecture that angular velocity is equals to angular displacement all over time. Now from this, see that angular displacement is equals to 2 pi in radians, 2 pi in radians all over time, 2 pi in radians all over time, and your time there is capital T, which is the period. So angular velocity is equals to, can be written as 2 pi all over your period. So period now, relationship period and angular velocity will now be equals to 2 pi over what? Over angular velocity, right? So, or you can say that angular velocity, okay, angular velocity is equals to 2 pi over period. So this equation, these two equations, they are very important. These two equations, they are very important. So take note of them. Take note of those two equations. Now, having known this, we know that frequency is equals to what? 1 all over period. Is that not? So which means that frequency will be equals to W over 2 pi from this above equation. So if we know, that means that angular velocity will be equals to 2 pi times frequency. So this is another equation that you should take note of. Angular velocity is equals to 2 pi times frequency. So these are three equations. Please take note of them. They are very, very important when you are solving problems that has to do with simple harmonic motion, right? So this is what I've discussed so far. So this is what I've discussed so far. Take note of these equations. They are very, very important when you are solving any problem on that has to do with simple harmonic motion. These equations are very, very important. Okay, so we want to look at simple pendulum, period of a simple pendulum. Now you know that the equation for the period of simple pendulum is given by t is equals to 2 pi square root of the length of the pendulum all over acceleration due to gravity. Now you can work this out. If you want to work this out, you square both sides of the equation. You have t squared is equals to 2 squares 4 pi squared L over G. Right, so this equation can also be written as t squared all over 4 pi squared equals to L over G. So depending on what you are asked to find, you might be asked to find the length of the pendulum or the period of the pendulum. So depending on what you are asked to find, you can make any of these variables the subject of the formula so that you can solve and get the unknown. That okay, now in a case where you have two pendulums that are oscillating together, you can relate the two by this simple equation that the period of the first pendulum all over the period of the second pendulum is equals to the square root of the length of the first pendulum all over the square root of the length of the second pendulum. So if you remove this square root sign by squaring both sides, you have that t1 squared all over t2 squared equals to L over L2, L1 over L2. So with this equation, you can actually compare two pendulums that are oscillating close together. You can use this formula to compare the two. Maybe you are asked to find the length of the second pendulum or the period of the second pendulum. This is the equation that you use. Alright, so please take note of all these equations so that you can use them to solve any problem that you want to solve. So this is exactly what I have said. For two pendulums in the same location, their period t and the leg can be compared with the formula this. So please, sorry about this, but so this is the equation that you can use to compare them. Alright, so we are going to solve some problems to drive home what we have discussed so far. Okay, so this is a sample question. So calculate the period and frequency of a simple pendulum that makes 40 oscillations in 35 seconds. So here you are given the number of oscillation, which is n, is equals to what? 40, and then we are giving time to be equals to 35. Okay, so the period t from the formula we got in before, period t is equals to time taken for one complete oscillation. That's the period t. So if you substitute that to this equation, all the value you have 35 over 40. If you do that division, you have that the period of this pendulum is 0.825 seconds. So this is what you have. Then for the frequency is equals to n over t, number of oscillation per seconds. Number of oscillation is 40 all over the time taken. So that will give you 1.14. If you solve that, 1414 hertz. Either you put it in hertz or per second, seconds per seconds. So this is the period for this pendulum, and this is the frequency for this pendulum, period and frequency. So this is how to apply these equations. This is another sample question that we'll need to also solve too. A ball timed 30 oscillations of a certain pendulum tries and obtained these following times: 1 minute 30 seconds, 1 minute 12 seconds, 1 minute 7 seconds. The mean period of oscillation of the pendulum is what? So here you are asked to find the mean period of oscillation of the pendulum. So which means that you are going to take each of the time, calculate the periods, then divide it by the number of periods. That will give you the mean period of oscillation of the pendulum. So the first time that is gotten is 1 minute 10 seconds. 1 minute 10 seconds. Know that period is equals to T all over N. That is period. So for each of them, you are going to calculate the period for each of the time. And you know the number of oscillation is 30. So each of this time you convert it to seconds. So 1 minute 10 seconds. So for the first set of time, 1 minute 10 seconds is equals to what? Is 70 seconds. The second one will give you how many seconds? 1 minute 12 seconds is equals to what? 72 seconds. While the last one, 1 minute 7 seconds, that will give 60 plus 7, 67 seconds. So if you have done that, you can now start to solve. For the first one, T is equals to time taken over number of oscillations, so which gives you 70 over 30. So you go down like that for all the rest one. The second one, T over N. For the second case, that is 72 over 30. Then the third case, T3, is T2, T1 as the case may be, right? Right, 67 over 30. So guys, if you work all this out, this will give you 2 point. This will give you 2.33 seconds. This will give you 2.40 seconds, and this will give you 2.23 seconds. So these are the various periods for each of the timing. So now what you need to do now is say find the mean period of oscillation of the pendulum. So the mean period is, you find the mean of these numbers. You find the mean. So which means you are going to add them up and divide by 3, since there are 3 set of experiments. So you have 2.33 plus 2.40 plus 2.23 all divided by 3. Okay, so when you work this one out, work that out with your calculator. If you work this out, you are going to have 2.32 seconds as your mean period. So your period mean is equals to this. So this is what you will have as your answer: 2.32 seconds. This is what you have as your answer. So guys, solve more problems so that you get used to how to carry out calculations on simple harmonic motion. Okay, so this is your test page. Please solve the questions. Don't shy away from them and don't be afraid of them. Solve them. Solve them on a piece of paper. Snap it and put it on the WhatsApp number that is showing on your screen. I will look at your method of solving and then give my own suggestions. Is that okay? So this is where we are stopping our class for today. Please guys, if you have not subscribed, subscribe to our channel, give us a like, give us a thumbs up, click on the notification bell so that when we upload a new video, YouTube will notify you. Also, you can reach us via the WhatsApp number that is showing on your screen. Alright, so I hope you are enjoying our lectures. Please invite your friends so that they can come and join our online physics class. So this is where we are stopping for now. See you in our next class.